All right. Here's the words up here. So parallel lines have the same slope, and then perpendicular lines have opposite reciprocals. So like you flip the fraction and you change the sign. If it's positive, it becomes negative. Negative, it becomes positive. Great. And then when you classify triangles, you're going to classify them by their sides. So here's the words we're going to use for that. You're also going to classify it by the angle. So there's the words for that. This one says use distance formula to find the side length. I'm going to do distance formula exactly one time because the rest of the time I'm going to do Pythagorean theorem. I feel like Pythagorean theorem is the easiest. Okay, so use the distance formula to find the side length. So from A to B, we're going to do big square root. And if you're like, where's the distance formula and what is it? It's at the top of the page right here. So my x1, y1, it just takes longer than Pythagorean theorem, so that's why we're doing this one time, and all the other times we're doing the shorter version. But I want to, show you how. So here's my points. x1, y1 is A. x2, y2 is going to be B. So let's plug those in. x1 minus x2, so 0 minus 3 squared. Where are these numbers coming from? It's the x value for A and the x value for B. You subtract them. You square them, you add them to the y values subtracted. So, oh, why did I put y? I don't know. I should put 0. 0. Why did I put that? I'm struggling, y'all. 0 minus 2. Thank you. Yes. And then I would plug all of that into my calculator, and I would solve. All right, you type it in your calculator, and you will get this number, so 3.6. So you can also, if you don't put the big square root in there, it would give you 13. And another answer that would also suffice is the square root of 13, because they're literally the same number. So 36, or you can put the square root of 13 if you don't, not 36, 3.6. If you don't want decimals, put square root of 13. Same thing. All right, now let's use Pythagorean theorem.
On the test, we have to do...
Okay, I'm going to take a different color pen. You can just use your pencil, that's fine. But if you have something that's a different color, maybe it would be helpful. Because we are going to draw a right triangle that goes from B to C. So if I start at B, and I'm like, okay, I'm going to go up to even with C. So I'm going to go up 1, and I'm going to go over a lot. 5. Over 5, up 1, 5 and 1. See? 1, 2, 3, 4, 5. You got to count the spaces in between. Another thing you could do is realize, okay, here's 0. It's 2 to the left and 3 to the right. 2 plus 3 is 5. That's another way you could determine that right triangle. And then, why am I making a right triangle? Because I am doing Pythagorean theorem to solve for the distance. So I'm going to solve for CB using Pythagorean theorem. So 1 squared plus 5 squared equals C squared. All right, let's type that in. 1 squared plus 5 squared equals 26. So C squared equals 26. You take the square root of that, and like I said earlier, you can use just the square root of 26 is fine, or you can say 5.1, because that is what the square root of 26 rounded to the nearest tenth is. Okay, hopefully that wasn't too crazy. If you understood that, great. If you're like, I don't know what just happened, I'm going to do it again. So let me show you. So going from C to A, all right, C to A, you're going to go down 3 over 2. Why do I do that? I'm creating a right triangle. So I start at C and go down all the way to where I'm even with A. And then I connect it over to A. So it's 3 and 2. That's a great question. So for the slope, yes, you will do that. For this, you won't, because distance is always going to be positive. So you just want to know how far from here to here it is. But really good question, because yes, it will be negative in like just a second when we do step 3. 3 squared plus 2 squared equals C squared. And yeah, the reason it's not negative is just it's like the length. It's the distance, and you can't have a negative distance. 3 squared plus 2 squared is 13. Ooh, we may be seeing a pattern here. Two things that are the same. Yes. So square root of 13 is 3.6. And if you don't believe me, it's there. There it is. Square root of 13, 3.6. So remember, it's up to you. You can just leave it at square root of 13 and be done, or you can switch it over to 3.6. I would just do the same. Like, be consistent as you go throughout either all decimals or all square roots so that you are able to compare them. Because that's the whole point of this. We are comparing the lengths of the sides. We will come back to this and at the end in just a second. So check for right angles by finding the slope. Okay, what's nice about Pythagorean theorem is we've already kind of found the slope for a lot of them. So from A to B, first of all, it's going to be positive. And I think the easiest way to determine that is like put Bob on that line. Bob, remember, he has a disease and he has to walk to the right always. If he's walking to the right and he's going uphill, it's going to be positive. So AB, start at A, it goes up 2, and then over 1, 2, 3. So it's a positive 2 over 3 for that one. Perfect. All right, and then the slope of BC. So I'm going to start at C. You don't have to start, even though it's called BC, you don't have to start at B. I'm going to start at C, and then if you put Bob on that line, he's walking down, so I'm just going to put a negative, like a minus sign right there, because it will be minus. It goes down 1 over 5. Down 1 over 5. Negative 1/5. All right, and then the slope of the last one, CA. So starting at C, it's going to be negative, because he goes down 3. And if you put Bob on that line and he walks to the right, ooh, he's going down. So down 3 over 2. So there's a couple different patterns that we're going to talk about when we're actually classifying this shape. So classify it as pick one of these 3, pick one of these 3. So we're going to do the angles first. So things that we need to look for. Well, first of all, there's no obtuse angles there. If you look at it, well, it's actually kind of hard to tell. It's both of them. Yeah, so you are looking at acute, right, or obtuse right now?
It's a right.
No, yeah, that's right. Oh, it's right. How is it? How do you know it's right?
Because the slope's perpendicular.
There we go. So we're going to write that. So there is one right angle because AB is perpendicular to CA. And if you're like, whoa, where did that come from? How does one even know that? Well, perpendicular means you flip it and you change the sign. So this is positive 2 over 3. The sign has been changed to a negative and it's been flipped. So instead of 2 over 3, it's 3 over 2. All right, and so I wrote one right angle. We know that there's one because it's just this one. These are the only 2 perpendicular slopes. And I wrote what's perpendicular to what. AB is perpendicular to CA. Okay, so that is, we're going to write the word right. And then, yeah, it is isosceles. And the reason it's isosceles is because these 2 are the same length. So they're both square root of 13 or both 3.6, depending on what you're looking for. So it's 2 sides congruent. A, B is congruent to C, A. Yeah, so for this one, it's nice because you only have to do Pythagorean theorem twice because one of them is AB, and it's literally just count the spaces in between. So from 4 to 9, it's 5 units long. That's easy. And then we're going to CA. Well, no, I guess let's do BC because that's next on the list. And you go down and over. So I'm drawing my right triangle. From C to B, it's 2 units down and 1, 2, 3, 4, 5, 6 units over. You would be shocked to see how many times people miscount this. C is at negative 6, B is at 0. It's pretty obvious that this is 6, but just so many times people want to make that 5. And I don't really know why. But alas. All right, so it's 2 squared plus 6 squared equals C squared. And then we type that in and we get 40. So C squared equals 40. We take the square root of both sides. And you get 6.3. All right, cool. So those are those. All right, I'm going to pause for a second. And I want you to solve for CA 7. All right, so none of the sides are the same. So it is going to be scalene. And you can go ahead and write that closest, because we're going to write that second. Scalene, because there's no congruent sides. And then the slope of AB is, all right, if you put Bob on that line and he walks to the right, he's going to die. His life is undefined. All right, and then the slope of BC, it's kind of nice when you do Pythagorean theorem because it's really already done for you. So it goes down 2/6. Make sure you simplify these. On the test, last year I remember having to take off points because people would not simplify. Don't let that be you. And then this one goes up 3/6, so 1/2. All right, and then it is also, so for this one, with the obtuse and acute, you kind of just have to look at the picture. It is going to be obtuse. No, sorry, it's acute. What am I saying? It's acute. I'm a crazy person. It is acute because no, and then no right angles, no perpendicular slopes. Okay, I'm going to pause this video, and this is your shape, but I want you to solve for everything. So right now is your chance to pause the video, because I'm going to come back on in just a second and show you the answers for this particular one. Alright, so if you haven't paused the video, do that. Solve it. See if you know what you're doing. This is what those final answers should look like. These are congruent, 10 and 10. This side is 6.3. So it's isosceles because A, B, and CA are congruent. And it's acute because there's no right angles and there's no obtuse angles either.